Okay, so today we're going to do lesson 5, multiplying polynomials. This should be the last of the notes in your packet. So polynomials are expressions that are mainly a combination of terms with both addition and subtraction that can have only constant and positive integer powers. They are truly just an extension of our base 10 number system. So in exercise 1, given the polynomial listed here, what is the value when x equals 10? How can you determine this without the use of your calculator? If you cannot, use your calculator to help, and then explain why the answer turns out as it does. Okay, so first we're going to go ahead and substitute 10 in for x, in which we've done this before in multiple lessons. So we have 2 times 10 to the third power plus 5 times 10 to the second power plus 3 times 10 plus 4. So again, our goal here is to not use a calculator. So 10 to the third power gives us 1,000. We have 3 zeros. Plus 10 to the second power gives us 100, gives us 2 zeros. Plus 3 times 10 is 30, plus 4. Well, 2 times 1,000 gives you 2,000. Plus 5 times 100 gives you 500, plus 30, plus 4. If you were to add these all up, you would get 2,534. Okay, we've already reviewed how to multiply polynomials by monomials in the last lesson. In this lesson, we will look at multiplying polynomials by themselves. The key here is the distributive property. So let's talk about the distributive property, and we're also going to talk about some binomials with the word product. So in exercise 2, consider the product of 3x plus 2 with 2x plus 5. So I'm not, sorry about that. Okay, so the word product just means to multiply. So product means to just multiply. So part A says find this product using the distributive property twice, or possibly foiling. So we're going to use foiling for this method. So I'm going to set this up that says 3x plus 2 times 2x plus 5. And so I'm going to go ahead and show you how you FOIL, just to remind you. So I'm going to take 3x times 2x plus 3x times 5, and I'm going to multiply plus 2 times 2x, and then 2 times the positive 5, so plus 2 times 5. So once I do this, I'm going to go ahead and combine everything. 3x times 2x, remember there's an exponent that's 1, so I need to add those there. So I get 6x squared plus 3x times 5x is 15x, plus 2 times 2x gives me 4x, plus 2 times 5 gives me 10. So I'm going to combine some like terms here. So I have 6x squared plus 19x, combining these two, plus 5. That gives me my product of the two binomials. Okay, so part B says represent this product on the area model shown below. So when we use the area model, we do this box method. So when I look at this, I am setting this up as 2x plus 5, which is there, and then the 3x plus 2. So you can think of it as this is being added to one another. Okay, so 2x times 3x gives me 6x squared. 2x times 2 gives me 4x. 5 times 3x gives me 15x. And 2 times 5 gives me 10. So these two diagonals, I'm going to add from top to bottom. So if I do that, I get 6x squared. 15x plus 4x gives me a positive 19x plus 10. So that's how we use the area model. Exercise 3. Find the product of the binomial 4x plus 3 with the trinomial 2x squared minus 5x minus 3. Represent your product using an area array. Then, even though the result has an x cubed term, the area array can still help us keep track of the product to make sure we are distributing correctly. So we're going to go ahead and draw out our area array. So if I draw this out, I'm going to draw a line through here, and I have 3 sections. So on the left side, I'm going to put my binomial, which is 4x and 3. On the top portion of it, I'm going to put my trinomial, which is 2x squared, minus 5x, and then minus 3. So I'm going to keep all my signs there. All of these in front are positive, but we just don't tend to put those. But we also want to put our negatives there. So let's fill in our chart. So 2x squared times 4x squared gives me 8x cubed, because remember there's 1 there, we need to add the exponents. 2x squared times 3 gives me 6x squared. Negative 5x times 4x gives me a negative 20x squared. Remember it's 1 there plus another one. Negative 5x times 3 gives me negative 15x. Negative 3 times 4x gives me a negative 12x. And negative 3 times positive 3 gives me a negative 9. So now I'm going to circle those things that need to be combined. Remember, we go from top to bottom. So if I multiply these out, I get 8x cubed, negative 20x squared, plus 6x squared gives me a negative 14x squared. Negative 12x plus negative 15x gives me a negative 27x and negative 9. So that is our new polynomial. It is critical to understand that when we multiply 2 polynomials, then our result is equivalent to this product, and this equivalency can be tested. So we talked about last unit what equivalent means. That just means they're equal to each other. Exercise 4 says consider the product of x minus 2 and 2x minus 5. Again, remember product means to multiply. Evaluate this product for x equals 4. Show the work that leads to your results. So we have the x minus 2 times 2x minus 5 as our product, and they want us to evaluate for x equals 4. So I have 4 minus 2 times 2 times 4 minus 5. So 4 minus 2 gives you 2 times, if 2 times 4 is 8 minus 5. So we have 2 times 8 minus 5, which gives us 3. Therefore, that equals 6. Part B says find a trinomial that represents the product of these 2 binomials. So in the last example, we could either use foiling or we could use the area array method. I'm going to choose to use foiling for this method. So I'm going to take x minus 2 and multiply it by 2x minus 5. So I'll have x times 2x, which gives me 2x squared. And then x times negative 5, which gives me a negative 5x. Negative 2 times 2x is negative 4x, and a negative 2 times negative 5 gives me a positive 10. So if I combine these two like terms, I get 2x squared minus 9x plus 10. So that is my trinomial from the 2 binomials, and that is using the foiling method. Part C says, evaluate the trinomial for x equals 4. Is it equivalent to the answer you found in A? Remember, equivalent means it equals the same thing as A. So let's plug it in. So we have 2 times 4 squared minus 9 times 4 plus 10. Again, we're going to try not to use our calculator to build our arithmetic skills. So we got 2 times 4 squared gives me 16 minus 36 plus 10. 2 times 16 gives me 32 minus 36 plus 10. Now I'm going to subtract 32 minus 36. That gives me a negative 4 plus 10. Negative 4 plus 10 gives me 6. And in fact, yes, it does look equivalent, because it does equal what part A was. So if you notice here, anytime you have two binomials and you multiply them into a trinomial, any value that you put in for both the binomials and the trinomials will always equal each other. Okay, exercise 5. The product of 3 binomials, just like the product of 2, can be found with represented application of the distributive property. Part A says find the product of x minus 2 times x plus 4 times x minus 7. Use area array to help keep track of the product. So when you have 3 binomials, I like to break them off into 2s and then multiply the last one of the third. So first I'm going to use the x minus 2 times x plus 4 in my area array. So on the side here, I'll put x minus 2, and at the top I'll put x and the positive 4. So I'll go ahead and fill this in. X times x gives me x squared. X times negative 2x is negative 2x. 4 times x gives me 4x. And 4 times negative 2 gives me negative 8. So combine those things that are like terms. So now we get x squared. We go from top to bottom. 4 minus 2x gives me a positive 2x minus 8. So that just takes care of the first 2 binomials. Now I have to take this binomial and multiply it by the last one, which is x minus 7. Still using the area array. So I'm going to have, I'm going to make this a little smaller. So I'll have 3 sections. My trinomial will go on top as x squared, positive 2x, and negative 8. And on the side will go x, negative 7. So let's fill in this chart. X squared times x gives me x cubed. 2x times x gives me 2x squared. Negative 8 times x gives me negative 8x. X squared times negative 7 gives me negative 7x squared. 2x times negative 7 gives me a negative 14x. And negative 8 times negative 7 gives me a positive 56. So we're going to combine those things that are alike. All right, so once we combine those things that are alike, we should get our final answer is x cubed. 2x squared minus 7x squared gives me a negative 5x squared. Negative 8x minus 14x gives me a negative 22x plus 56. So this is my polynomial by multiplying the 3 binomials. Part B says, for what 3 values of x will the cubic polynomial that you found in part A have a value of 0? What famous law is this known as? So we're going to take these binomials here and set them each equal to 0. So that means we have x minus 2, set that equal to 0. We have x plus 4 equal to 0. And x minus 7 equal to 0. So I'm going to solve. Add 2 on both sides. That means x equals positive 2. I'm going to do the opposite, subtract 4 on both sides. And that gives me x equals negative 4. And then I'm going to add 7 on both sides. And that gives me x equals positive 7. So for x equals 2, x equals negative 4, and x equals 7 are my zeros. And we call this the zero product law. So for part C, test one of the 3 values you found in B to verify that it is a zero of the cubic polynomial. So I'm going to choose the first one. I'll go ahead and choose x equals 2, and I'll plug that into my trinomial and see if that gives me 0. So I have x, so I plug into 2 cubed minus 5 times 2 squared minus 22 times 2 plus 56. So 2 cubed gives me 8 minus 5 times 4 minus 22 times 2 gives me 44 plus 56. And we're going through order of operations. So we have 8 minus 20 minus 44 plus 56. Now if I go from left to right, 8 minus 20 gives me negative 12 minus 44 plus 56. Negative 12 minus 44 gives me a negative 56 plus 56, which in fact equals 0. So we verify that any of that values for x I plug in for 2, it will give me 0. The same will go if you plug in negative 4 as well as 7. So make sure you pause the video as much as you need to and write down everything you need, and we'll see you guys tomorrow.